Now in today's topic, we are going to consider the areas of similar triangles, and the learning objective is to show that two triangles are similar and also to work out the scale factor between similar triangles. And this is our keywords we have. But before we embark on this, students should have covered work on scale factors, linear scale factors and enlargement, simplifying ratio, and solving. We have done this in our previous lesson. Okay, now let's consider these two triangles A and B. You can see these two triangles are similar because one is just the enlargement of the other. So in these two triangles, if I have this side, maybe I have this side to be 4 cm and I have this side to be 12 cm. You know that the two sides are corresponding side. They are corresponding side, and we have done this in our previous lesson, that to find the scale factor, for us to find the scale factor, or we call it the linear scale factor. The linear scale factor, we take we start from the known to the unknown, and the known we have here are the two corresponding sides. The two corresponding sides are 4 and 12. So we divide it, the enlarged one 12 divided by the small one 4. So that gives us what? 3 cm. So 3 cm is our linear scale factor. You get that? Or let me start and say 3 is the linear scale factor of this. And if we want to move to find another side from here to here, we multiply, because we are moving from small to big, we multiply. If we are moving from big to small, we divide. We treated this in our last lesson. Okay, now from this case, if we are asked to find the area, maybe if the area of this small triangle is 20 cm squared, if we are asked that the area is 20 cm, and we are asked to find the area of B. So if you're asked to find the area of B, what you have to do is, first of all, first thing you are going to do is find the area scale factor. Don't use this scale factor. This one is the linear scale factor. We use it for the side. So we find the area scale factor, and the area scale factor simply means the square of the linear scale factor. You get that? So since the linear scale factor is 3, the area scale factor will give us 3 squared, and that gives us 9. Therefore, for us to find the area of B, the area of B simply means I'm transferring from here to here, so I'm going to multiply. You get that? But if I'm looking for the area of A, I'm going to divide. So I'm increasing. Since I'm increasing, I have to get that to be 20 multiplied by 9. So 20 multiplied by 9, I think that will give us 180. Okay, let's check. 20 multiplied by 9, that gives us 180. So we have 180 cm squared. So 180 cm squared will be the area of B. You get that? So you have to note that, you must note that if the linear scale factor, is K, then the area scale factor must be K squared. See that? Okay, let's look at this question now. For this question, it says that if the area of A is 28 cm, the area of this is 28 cm, we are asked to work out the area of B. For me to work out the area of B, first of all, since we are talking about area, I'm going to look for the area scale factor. And I cannot find the area scale factor without first of all find the linear scale factor because the line of the side of the corresponding shape are given. So the first thing I'm going to look for is the linear scale factor. And the linear scale factor there simply means the large one divided by the small one. 6 divided by 4. So if I divide 6 by 4, we have that to be what? 6 divided by 4. That is 1.5. So 1.5 is the linear scale factor. Then to obtain the area scale factor, I'm going to find the square of the linear scale factor. You see that I'm going to find the square of the linear scale factor, and the square of the linear scale factor now will give me what? That gives me 2.25. 2.25. So the area of B, since the area of A is 28, the area of B will be 28 multiplied by the area scale factor. Okay, so area of B will now be what? 28 multiplied by the area of the scale factor. So that gives us what? This multiplied by 28, 63. So 63 cm squared is the area of B. Okay, let's look at this question here. In these two questions, it says that A and B are similar, and the area of A is this, while the area of B is this. So we are asked to find y. Now, if I have to find y, what I'm going to do is that since the area is given, that means the area will produce the area scale factor, while the side will produce the linear scale factor. So note two of them. So I'm going to find the area scale factor. The area scale factor simply gives me the large one, 75, divided by the small one. I'm talking about area now. So that will give me what? 75 divided by 12. We have 6.25. We have that to be 6.25. So 6.25 is the area scale factor. So for me to look for y, I'm going to talk about the linear scale factor. Therefore, the linear scale factor will now be the square root of 6.25. You get that? I'll find the square root of this, and the square root gives me what? Square root of 6.25. That gives us what? 2.5. So the linear scale factor is what? 2.5. So then y will be, since I'm moving from small to big, I will multiply. Y will be 4 times 2.5. So 4 times 2.5 gives us what? 2.5 multiplied by 4. We have what? 10. So the value of y is what? 10 cm. Okay. Now let's look at this also. In this case, it says A, B, and C are equilateral triangle. If B is 5 times the area of A, B is 5 times the area of A, work out the linear scale factor. Okay. B is the area. You don't know the area of A, but I can say let the area of A be small a. Let the area of A be what? Small a. That means that the area of B will be 5 times A, because they said if the area of B is 5 times this area of A. So if the area of A is A, that means the area of B will be 5 what? A. Okay. Now from here, in these two, I can find my area scale factor. So I'll find my area scale factor. Area scale factor gives us area of the large one, 5A, divided by area of the small one, A. That gives us what? 5. See that? This is the area scale factor. So for me to find the linear scale factor, I'm going to find the square root of this. Therefore, the linear scale factor gives me the square root of 5. So the square root of 5 is what? What do you have as the square root of 5? We have that to be 2.2. Okay, 2.2 to the nearest 1 decimal place. Okay, so the linear scale factor is 2.2. So that's how we obtain that, 2.2. Okay, now the next one said, what is the value of x? For us to find the value of x, we make use of the linear scale factor. So the value of x, since we are moving from small to big, we multiply. Value of x will gives us 7 multiplied by 2.2. So 7 multiplied by 2.2 gives us what? 7 multiplied by 2.2, that gives us 15.4. 15.4. So 15.4 is the value of what? Of y. Now the next question says, if C is 3 times the area of A, C is 3 times the area of A, what is the value of y? Now C being 3 times of area of A, that means if area of A is small a, the area of C will be what? 3a. See that? Now from here I can find the area scale factor, which gives me 3a divided by a, and that gives me 3 is the area scale factor. So from here I can now find the linear scale factor. So the linear scale factor simply means the square root of the area scale factor. So the square root of 3 will be what? Square root of 3, that gives me 1.7 to 1 decimal place, 1.7. Get that? So y will now be 7, because we are comparing A and C. 7 multiplied by 1.7. So 7 multiplied by 1.7 gives us what? 7 multiplied by 1.7 will give us what? 11.9. So we have that y is 11.9. So the value of y is 11.9 cm. Okay, so what you need to note in general here is that if we have the linear scale factor to be x, then the area scale factor will be x squared. Also, if we have the area scale factor to be y, then the linear scale factor will be the square root of y. So note this. That's how we solve the problem. Thank you for listening.